Welcome everybody, this is a time machine. Today we will travel in time. Say hello in the chat, can you hear me? Welcome to today's talk about temporal data management. Yeah, is there a time machine? Are there DeLoreans? Maybe you might say no, it is not possible to travel back in time. One argument people always say when talking about time machines, no, if it would be possible to travel into the past, then somebody would already have visited us from the future. Then you could say, okay, maybe it's only possible to travel in the future, but we will not talk about that today. We will really talk about traveling into the past. But then there is another theory that traveling in the past, it's called the, I think, receiver theory, that you need a receiver, and only when this receiver, this time travel receiver is invented, then it's possible to travel back in time to that point in time the receiver is invented. So as soon as this device, the time travel receiver, is finished, then people from the future will come and invent and visit us from the future. But first of all, we need to invent this receiver. We will build such a receiver today, but not for real life, but for relational databases. The idea is there's an SQL extension where you say select blah 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 from blah 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 for system time as of last week, Wednesday, 12 o'clock. So give me the result of this query that was valid, that was true, last week, Wednesday, 12 o'clock. But this, in general, of course, is not possible. We have to activate this first. We have to say, hey, MariaDB or DB2 or Microsoft SQL Server, please enable historization. This is a feature called system managed time and or transaction time, and this means internally when you activate this feature for a table, each insert, update, deletion on a table will be logged so that you can travel back in time to take a look what was the result of that query last week Wednesday. A lot of things happened since last week Wednesday 12 o'clock. There were some truncate tables, insert, update, delete, a product price was updated, a product was inserted, and so on. But this feature is really nice, and we will talk about that today, and we will talk about temporal data management in general. So the thing that I called system managed time will be the last part of today's talk. First of all, we talk about times in SQL in general. You all know the date data type. Date consists of year, month, day. So when you have a column for storing a hotel booking, somebody wants to book the hotel from the 29th of June 2021 to the 5th of July 2021. Then it's sufficient to have a date column because the hotel booking is not really related to a timestamp, to hour, minute, seconds. But when you want to store the information, when was this booking made, then you use a timestamp and store the current timestamp there. This is useful to make queries afterwards. How many bookings were in the last hour? What's the most popular hour of the day when the people make the most hotel bookings, and so on. So you all know date and timestamp columns. And SQL did not invent a new thing. They invented a new thing, but they did not invent a new data type. So we will talk about dates and timestamps and everything that was built on top of that in the last years in SQL Temporal. That's a standard. No, that's dbeaver. Yeah, in the chat you can ask questions. Simply write them whenever you feel that you have a question. The motivation. Let's take a look at this non-historized or temporalized table. So this is a classical table, products. Select price from products where the product number is 21. You all wrote those queries. And you all wrote those queries, oh, I changed the price. The information about previous states are no longer available. Let's talk about databases, how you learn them in university. You learn them completely wrong. When you learn databases and tables and SQL, then you have customers. Each customer has an address, and each customer has a first name and a last name, and each product has a description and a price. And a customer orders a product, and you store when does he or she order the product. That's how you learn databases in the university. In reality, you have to track changes. It is not sufficient in all applications to just say, oh, update customer, he or she married, so the last name is now Miller and not Smith anymore. You want to keep the old fact within the database so that it is not lost. Otherwise, you get an inquiry about a person called Smith, and then you search in the database. No, we don't have a person called Smith because he or she changed the name to Miller, so or other way around. It is important for insurance companies, for banks, for everything to keep a track of the changes. And you have two possibilities to do that. First of all, manually. You could make a table on this date the name was that, and as of this date, from that day on, the name was this and that. So you store manually in a table in some columns, valid from, valid until or something, when was a fact valid. And then you simply don't override, but you add an additional row with a new fact from the new validity date. Then you have access to the previous states and access to the current state. This approach is very popular, and this approach also works for dates in the future. So you can say the current price of the dishwasher tabs is $3.99, but this is a special offer. Next week it should be more expensive. Next week it should be $4.99. So you can already insert a row that shows not only the historical prices. The price of the dishwasher tabs was $1.99 5 years ago. That was very cheap. And then you can build a chart. How did the price evolve? You can also insert something that will be valid in the future. That's application-based time. So the application or the user has to manually store these events and when they are valid in tables where you add some timestamp columns or date columns. And the other approach, we will see that the system manages this automatically, but then of course it's not possible to work in the future. Here are some other scenarios. So one scenario would be a web shop where you update a price, and Peter orders the dishwasher tabs last week, and you want to take a look at what was the price when Peter ordered the dishwasher tabs. If you updated the price and you don't have an information anymore, what was it last week, then how to calculate the revenue of last week? So tracking changes is important. I already mentioned the bank. There it is always important, so-called auditing. Auditing is a feature that logs everything that is happening. So to afterwards understand what happened. It is very important in banks that everything, every change is tracked. So it helps understanding the data and understanding why something happened. So the bank needs access to all changes in customer data. The bank needs to know your old address and your former address before that change and so on, and changes in names, changes in some other customer data. An insurance company needs to store the fee for specific time periods. Let's say you insure your bike and this year the insurance fee is $80 per year. But next year it will be $85. And your neighbor has a special offer. He used a voucher code. Okay, that makes no sense for the time tracking. But yeah, from this point in time to that point in time, the insurance fee is 80, and from that point in time to that point in time, that can be in the future or in the past, it is $70 or $90. So it is not constant, but you want to say from that point in time to that point in time, it is that amount. And then you may ask queries with a group by and a count and a where you want to know how much euro did Peter pay for the insurance in total. And then you have to be careful to use the correct prices. Predictive analytics. They analyze the past. These are algorithms that analyze what happened in the past. For example, users clicked on these products in the web shop and bought those products. And then you predict the future. You want to predict how many of those products will be sold in the next week. This is good for warehousing. So not data warehousing, but a real warehouse where you have your shelves full of shoes or TVs or whatever. You want to predict how many TVs or laptops or whatever should be in stock based on a prediction of the past. So you analyze what happened last week, what happened last year to make a prediction. And a last example that I used here is a travel agency wants to detect inconsistencies. So we store when somebody rents a car. Peter rents the car in Rome from the 1st to the 5th July, but this overlaps with a hotel reservation in New York. So the same customer, Peter, reserves a hotel from the 2nd to the 12th July in New York. So for some days, the same customer has a car on the other side of the world than a hotel. So you can detect such an inconsistency then and call the customer or give an error message when booking. So what we need is the concept of time periods. Currently, when we talk about dates and timestamp, these are only points in time. Order date, order timestamp. This is just when did Peter place this order. This is just a point. Now we want to talk about periods from Wednesday to Friday, from Wednesday 12 o'clock to Friday 12 o'clock or something. So we want to talk about time periods, and a period of time is defined by two dates, a smaller date and a larger date, and that's a time period. That should be very easy. One approach which works in every relational database system is manually storing periods in two additional columns. Here I simply use date for that, because for simplicity I simply say there are not multiple changes within one day. So what I have here is my products table. A product has a product number, a description and a price, and so this table is how you learn it. And now I add two columns, and this is a very, very popular approach. So in database design, in data vault, this is a data model and so on, and in many companies and enterprises you find valid from and valid until columns to make a temporalization. And this is not a feature of databases. This is just you do this for tracking when is something valid. Of course, this product number is now not a primary key candidate anymore, because you have the same product multiple times. Product number 29, product number 29 is costs $3.99 from that date to that date, and from that date to that date infinity or something it is $4.99, and then again 29 is the product number. So product number is not only a valid a valid primary key anymore. What would be a valid primary key here? When you take a look at this table, write in the chat what would you choose as a primary key here. Product number is not a primary key anymore. Write in the chat. So one approach is not using a primary key at all. That always works, like I did here. But what would be a primary key here? One suggestion, product number valid from. That's perfect. That's definitely unique. Product number valid from, valid until. This valid until is not necessary. So it would also be a valid primary key criterion here, but valid from is absolutely sufficient. So product number and valid from, because we don't have multiple valid froms for the same product, because it's important that these intervals do not overlap. How to avoid overlapping time intervals? So you could imagine writing a check constraint here, but this is a homework for you and it takes several minutes to define. Yeah, and to define that no two rows have an overlapping interval here. From and until, do these intervals overlap or not? We will take a look at such queries later. This is not really not really nice. You have to think a lot. So here is the interval. This was from Monday to Friday, the price was $3.99, and then from Friday to Wednesday in the next week the price was $4.99 or so. And this would be an overlapping time interval. And you can now say let's say start 1 and end 1 and start 2 and end 2. Yeah, write some Boolean expression that is true when these two intervals overlap. So yeah, we will not do this today. We will have it on a future slide soon. It is not so hard, but it's not so easy that you can simply say, it's when S2 equals blah, 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 and greater than that and that and that. So this is one challenge, how to overlap time, how to avoid overlappings in these time intervals, because we don't want that for the same, so that's the definition of overlapping, two time intervals overlap when there is one point in time that is in both intervals. And that's not what we want. When I want to ask, what was the price of the dishwasher tabs last week, Wednesday, 12 o'clock, then there should only be one row that shows me that. Maybe there's no row because the dishwasher tabs were not inserted yet or something. But there should definitely not be two prices. The primary key suggestion of one user was concatenating using a Unix timestamp and PNR. Two problems. So please don't use Unix timestamps here. We have the date data type, we have the timestamp data type. So don't use Unix timestamps and integers now. And don't use concatenation because primary keys can be compound, so with a comma. So PNR valid from is my favorite primary key for that table that we have here. Yeah, and how to avoid overlapping. I said you can use a check constraint here, but with a check constraint this would not work in many databases because it is, for example, in PostgreSQL not allowed to use a subquery in a check constraint, and you would need a subquery because not only this current row that is inserted must be checked if it's valid or not, but all other rows should be inspected as well, so to check that they don't overlap. So this is not so easy to guarantee. You need a trigger or something. This is not fun. Yeah, and trigger is another important keyword here. I have this in the last challenge, how to add real temporal support on top of the database management system, because you do not want to manually set these timestamp. I added two default values which make it a bit more comfortable. So when I insert a new product, then it is valid from the current timestamp up to the maximum date, or current date because it's a date, and up to 999/12/31, so the maximum date from now until infinity, or eternity. Yeah, until forever. But of course, when you want to change a price, you have to change the valid until date. You have to do many things manually. And when you want that the database system does this kind of automatically, you can install some triggers. For example, you create a trigger after delete on this product. Don't really delete that product, but insert it again and set the valid until date up to the current date or something. Or you make a trigger which, when you execute an update query on the products, that it inserts a new row which stores the previous state before the update. So you can use triggers for that, so that you can work in the end in the database as if it would be a normal table, and the trigger takes care of setting these from and until dates and takes care of the historization. Yeah. You can, as an alternative, also use stored procedures. So when you insert a new product, you can use insert. When you update the price of a product, then you don't use update, because then the old price would be lost. You call a procedure that you create on your own, which you call update price. And in this procedure, the price is updated, the previous price is stored as a historical row with a valid until date to today and so on. So these procedures do this work for you. Yeah, and constraints you can add to avoid that some inconsistencies occur, for example, overlapping time intervals, or that the time intervals don't have any gaps or so. You can do this with constraints. As I said, check constraints are not very powerful in most database management systems, because they are only row level constraint and you need table level constraint. Then you make your constraint with a trigger, which checks after an insert, update, delete if everything is okay. If not, then the transaction is rolled back. Question in the chat. Assumed you have not the support of temporal tables from a DB engine. That's what we are talking about. Would it be easier to drop the valid until and sort for the biggest date which is valid automatically? That's a very good question. So we have here valid from and valid until. The suggestion in the chat is, what would be if we only have valid from, and valid until is either infinity or the valid from the next row. So the next bigger valid from value. And that's the problem, because it's costly in SQL to find the next value. So the reason why we have from and until is its simplicity when we afterwards white select queries. So yeah, you could let's do this. Let's say we don't have a valid until. So I create a new schema, create schema modern database concepts 29th of June. I'm connected. Today I use MariaDB. Okay, MariaDB doesn't have schemas. So let's refresh. Yeah, yes, MariaDB has schemas. MariaDB has a catalog, and I simply call the table differently because I'm not good in MariaDB. Let's call it X products. Okay, now we have a table called X products, and there is only a valid from. So I insert into my products table and write the product 29 is called dishwasher tabs, and it costs $3.99 from the 1st of January, let's say. And then on the 1st of July, it becomes more expensive. Then you could, for example, make a view that adds the valid until because we need valid until for making easier queries. What was the price on the 1st of June or something, or the 15th of June, is not so easy when you just have the valid from. So let's add the valid from here, and for this you can use window functions. This is a very powerful feature. Window functions are like aggregation functions. You can write running sums, running averages, and so on. So you define a window. So let's just for testing, define a window. You define a window with over, partition by, and now what's the same product in this case? So partition by P&R adds now a column which shows 2 in our case. If you would have another row here, 17 chocolate bar 89 cents, then it would be a 1 here. Yeah, here's the chocolate bar. So it's just, it is like a group by, but not really reducing the result set. So with a group by, you would have only 2 rows here, 1 dishwasher tubs row and 1 chocolate bar rows. Here we have our original table, we just add an additional information. And or you say average price. You find the average price for the product which we are currently looking at. And then there is a feature called leak and lag. Lead is the next value. So what is the next value when you would order by valid from? And that's what we need. This from the chocolate bar doesn't have a next value, so it shows null. And this from the dishwasher tubs has a next value when you would order it by valid from, so it shows that. So you see, this way we can reconstruct the table and maybe build a view that lets it look like the table from before. And then you can coalesce to use here the 9999, 1231. Coalesce is a function with arbitrary parameters, and the first parameter, which is not null, will be chosen. So now the table looks as before. Yes, it is valid, but then you have to make this step here, and it is costly. So each time when you now query this view here, this computation has to be done. That's the reason why typically you have valid from and valid until columns. Yeah, another question which has to be considered, are the intervals open or closed? So is our 1st of July included or not? Is this date, was the price 89 cents on the 1st July or from the next day? So the 2nd of July. So or this row here is very interesting. Is the 1st of January included in the time interval, or is it greater than, greater equal or greater than, smaller equal to the 1st of July or less than? So this is very important to define somewhere. Isn't the problem also that deletion is not possible without an until column? Yes, exactly. That's a good point. The until column makes it possible to really make rows invalid forever, and that would be not possible anymore. That's a very good point, yeah. also called tombstones, Grabsteine. So a placeholder in the table which stands for this is not valid anymore, but if you want to know it was valid then and then. Yeah, another challenge when you choose such a design is how to write temporal queries. So give me the price that the product 29 had last week Wednesday. Yeah, it is not so not so complicated. You use greater equal and smaller equal or greater than, depending on if the interval is open or closed. Yeah, the rest we had. In SQL, it took a long time, so the idea was very early, but they added it in 2011. They added the so-called temporal support, SQL Temporal. And 3 things were added in the SQL Temporal standard. First of all, the concept of time periods. You give time periods a name. You give time periods a name. You give time periods a column of the valid from and the column of the valid until. So you reuse dates and timestamps, and a date period is defined on the 2 already existing columns. So when you want to add a time period to your table, like we did before, you define your columns, blah, blah, blah. Here are 2 date columns or 2 timestamp columns. And then you write comma, period 4, then you give it a name, and then the 2 columns. And this makes it now possible to work directly on this period. And these time periods are very comfortable because you have now operator like overlaps, contains, finishes, starts with, intersects, don't know. So you have Allen's operators. Allen is a mathematician or computer scientist, or was, don't know. Allen's operators are a very famous set of operators, how 2 time intervals, yeah, how they can relate to each other. And the second thing the database can do for you when you define a period, you can say without overlaps. That's really nice. So then the database guarantees that there are no overlaps in this time period here. The second feature, which was introduced in the temporal standard of SQL, is application time period tables. This is basically the thing which was already possible in 1999. This is already possible in 1999 to add simply 2 columns in your table and then use greater, equal, between, and so on. But now with this new concept of periods, new operators were introduced in the SQL standard based on Allen's operators. For example, date period contains and then a date. True or false? Yeah, it finds those rows where the interval contains this date. For you, it is comfortable to write because this is only 1 row. Otherwise, you would need to write where d.date greater or equal the 1st of June and d2 less than 21 1st of June. And you have to be careful, is it an open interval? Does it include it in the start or at the end or not? And here the database does this for you. So you really do not need to care if it's an open or closed interval. It translates this contains query on the period into a predicate on the 2 date or timestamp columns that define the period. And the third thing that was introduced in the standard is system version tables. This allows historical queries. So select star from T is a query that you know. And in the from clause, it's now possible to write after a table when you activate system version tables for system time as of blah blah blah, or for system time from this time to that time. So you can travel back in time and you say, give me the result of that query that was that would be the result when I would have asked this query last week. So, and then you can hide all the timestamps and valid from and until if you want from the user, that the table for the user looks as a normal table. And by default, only the current state of the table is shown. Select star from T shows the current state, but you have access to older states. So, temporal, four features were introduced. Temporal tables. I don't have a description here, but I will have a slide at the very end of today's lecture. Temporal tables are the combination of application time and system version tables. So you introduce columns and a time period when something was valid to when something was valid, and this table is system versioned. This is very can be confusing, but we will make an example later. Okay, that's our agenda for today. Let's start with these time periods. I already told you one example here, period 4, and then you give the period a name, because when you want to query on that period or you want to include that period in the primary key, then you use the name of the period. Here's now a bigger example. Our products table. Create table products. Each product has a product number, then a description, then a price, valid from, valid until, and we define a period for this valid from and valid until and call it date period. The SQL standard now allows primary keys including the period. So typically it would be useful to say the primary key consists of PNR and the date period. I will use MariaDB today for all my examples because in the other lectures I used PostgreSQL, but PostgreSQL does not have a temporal support, so I have to choose another database system, and MariaDB does not support primary keys including the date period. So MariaDB supports periods, but it's very limited. So you can define a period, you can define a unique on that period, so that you say PNR and my date period is unique. It also supports this with overlaps clause, which is in the SQL standard. So it's not really unique that valid from and valid until must be exactly the same value, and the PNR in this case. So what we know as being unique. The with overlaps detects a conflict as soon as there are 2 points in time, as soon as there is 1 point in time which is in both intervals, then it is an overlapping in the interval. So it's okay that two intervals are just after each other. So we call it, so Allen's operator is called finishes or starts. So P1 finishes T2. P2. So when this interval is finished, so the valid from time from the second interval is equal to the valid until of the other interval. That's okay, but really overlapping is not okay. We now have to talk about open and close intervals, and I tell you the solution that the SQL standard describes. valid from is included. So the price of the chocolate bar was 89 cents on the 1st of January, yes. And this valid until is not included. So it is smaller than valid until. So 1 second before, or 1 time unit before that valid until timestamp, the interval ended. So you can write intervals in, so when you write Monday to Friday, you can write it like this. Then it's Monday, Tuesday, Wednesday, Thursday, Friday. But here we use it how the SQL standard defines it. Friday is not included, so it's an open interval. So this is basically Monday, Tuesday, Wednesday, Thursday. This makes it possible that the next interval can start on the date where the previous interval ended. So from Friday to Sunday would be the next interval. Yeah. And these intervals do not overlap, even if both have the Friday but this does not really have the Friday, and it ended 1 time unit before the Friday. So the chocolate bar costs 89 cents from 1st of January, and on the 1st of July it is 99 cents. So when you order it on the 30th of June in the evening, tomorrow in the evening, then you get it to the cheaper price. I just realized that I did not have again my power connected. This is important. Yeah, in MariaDB it does not support primary keys. Unfortunately, it also does not support Allen's operators, the contains and so on, what we saw on the previous slide. This is defined in the SQL standard, but unfortunately not possible in MariaDB. DB2 supports it. By the way, there's a nice website called modernsql.com, which has an overview about a lot of SQL features, and it shows such matrices here, which system supports what and what not. So this for system time, what we look at today, is supported by Google's BigQuery, by DB2, MariaDB, so the Linux and Windows, Linux, Windows version of DB2, but I guess also the mainframe version. MariaDB supports it. Some variations is the comment here. And Microsoft SQL Server supports it, but SQLite, PostgreSQL, Oracle, MySQL do not support it. Oracle supports other things for supporting what we do today. What we will not take a look at that. So now we have a time period column in our products table, which simply allows us to track changes manually by using a date when something was valid or will be valid and until it will be valid. With the unique with overlaps clause, we guarantee that there are no overlaps. So when I would try to insert a row and say from April to December on 2021 the price will be that, then an error would occur because there would be an overlapping in this time period. Now let's take a look at some operations. The SQL standard uses Allen's operators and gives them a bit different names, but yeah, Allen's operators are operators on Allen's interval algebra. Yeah, here. This is a very nice picture. So we have two intervals, in our case time intervals, and some interval is before another interval, so precedes. Some interval meets but does not really overlap, they just meet. These intervals overlap. These intervals, starts and finished, that was a term that I used 5 seconds ago. Starts means they start at the same point and the other one continues while this is finished. So x starts y is this picture here. X during y is it starts so it is fully containing the other interval. X finishes y is the same, so the one starts while the other is ongoing and both finish at the same time, and then x is equal to y is when the start and the end are equal. And there are operators in SQL, in the SQL standard, which are based on these intervals. First I used this contains because contains was here on the list. Y contains x. So this interval fully contains the other interval. So each moment in time that is in the x interval is also in the y interval. There is no point in time in the x interval which is not in the y interval. So it really contains the full interval. Let's say you have a hotel booking from Monday to Friday and a car rental from Tuesday to Wednesday. Then the hotel booking contains the car rental interval. But contains is also an operation which does not only need two periods, two intervals, but it also works if it is a period and a point in time. So that's why I list it here. So date period contains a specific point in time. True or false? So please go to frage.de, Frage with 2a, and rewrite this query for me. So P and R is 17 and so the part after the end, please. So let's say MariaDB does not support contains, and that's the case. Then please rewrite that query and use smaller, smaller equal, and so on. In the chat, there's the question, you use date. Does this also work for date time? Yes. We can use timestamp here. I use date because it makes my queries shorter, that I don't need to write timestamps here. But yes, the SQL standard says periods can be defined on date, date, or timestamp, timestamp. So 20 seconds left. 8, 7, 6, 4, 3, 2, 1. Okay, 21 answers. Yeah, most are correct. It is a bit, yeah, you have to think a bit. And the yellow answer is, of course, the correct one. So in our valid from column, we have something which is smaller or equal than, so it began to be valid before that point in time. And it should be valid, so the valid until should be in the future of that point in time, and really in the future, because the 29th, if it would be equal valid until 29, then this valid until would not be included anymore because it's an open interval. So most of you have it correct, and you should be able to translate these queries into smaller equal, greater equal in the exercise, because MariaDB does not support these operators and you have to manually do this. For contains, it's quite easy, but for the other operators here, it's a bit, you have to take a cup of coffee and then think and draw a picture on a piece of paper to think when do dates overlap. Some people gave the blue answer, and this blue answer doesn't make any sense because here I don't use the 29th of June, right? So, and this is an overlaps expression. So I show it to you here. Contains, no, not an overlaps, and contains with a period. So does the date period contain this period? So this finds a row when a price was valid the whole interval from the 1st of May to the 15th of May. If it changed in between, then this query would not find anything, but in our case it would find this row here, because this interval here contains the interval from the beginning of May and the mid of May. And this one contains period. You would rewrite with the 1st of May would be greater than or equal valid from, and the 15th of May is less than valid until. So I prefer writing it in that direction to say this date greater equal valid from. You could also write valid from less than equal that. So it's yeah, it's my taste. Yeah, so contains works for points and for periods. And these other operators, which only work for periods, that the SQL standard defines, are overlaps, equals, precedes, succeeds, immediately precedes, and immediately succeeds. So when you use DB2, for example, you can use those intervals here, and you can yeah, construct your own period by writing period and then comma separating two dates, and then you can ask if an interval overlaps another interval. So when you have the hotel bookings and the car rentals in two different tables or so on, you can make a temporal join to check whether two intervals overlap. So they are overlapping if there is at least one point in time which is included in both intervals. Equals means they are completely equal, so each point in time of the blue interval is also in the red interval and vice versa. Precedes means the red interval comes before the blue interval and immediately precedes. There is no gap in between. And succeeds is the opposite. So the red interval comes after the blue interval. It starts after the blue interval is finished, and immediately it starts immediately after the blue interval is finished. So these operators are defined in the SQL standard and they are based on Allen's operators. Yeah. In the standard and in DB2 you could use them. In MariaDB I hope that they will be implemented in the next versions. Currently they are not implemented yet, so you have to manually rewrite what you want with greater, equal, smaller than, and so on. But at least MariaDB supports this without overlapping clause in the unique constraint, so that it checks whether two rows don't have an overlapping time interval. You use these time intervals for application time period tables. This means you have a table where you as a user or you as the application have to manually set and update the valid time periods. You have to set when something gets invalid. You can, as I said, use trigger or stored procedures for semi-automizing or automizing that, but you have to be careful to do this in the right way. So when I insert a new product, this is very easy. I either say the price or the full row is valid from then to then. I can use an interval which started in the past and goes to the past. So the price was 89 cents from then to then, or it was 89 cents and will be valid until that date in the future. So you are very flexible to use any times or dates here from the past or future or today or whatever. So you can define when something is valid. You can store in a table the presidents of the USA. From that point in time to that point in time, he or she, I think it was so far only he, was president of the United States. And then you keep track of the last hundreds of years. When you update, the SQL standard for application time period tables gives you a really nice syntactic sugar, which makes updates possible on the based on the time periods. So you can say update products for portion of time period. So this is the period that we defined in the create table command. So you don't have to, yes, you have to manually set the time periods, but you can use queries for that, which are introduced in the SQL standard. You can say for portion of time period from the 1st of February to the 1st of March, not including the 1st of March, the price was 50 cents of the product number 17. My question to you. Let's say we have two rows about product 17. From January to the end of June and from July to forever. So we currently have two rows and then we make this update. How many rows, go to frage.de, how many rows do we have in our table now? I will create this table. So after this update here, how many rows do we have then? So I have a chocolate bar which costed 89 cents. From January to July, and 99 cents from the beginning of July. So this is my table so far, and I fire now this update query here. I show you the solution. Wow. Most of you are not correct. So let's take a look why it is 4. So think a bit, maybe you realize why it's 4. I simply give you the solution by querying the table. So currently we have 2 rows. January to July, July to forever. Now I make this update, set the price of the product 17 to 50 cents for the interval February to end of February. Now there are 4 rows. Let's say order by valid from. January to the end of January, so before this price was changed. Then from February to the end of February, it was 50 cents. Then again, the old interval, maybe you missed that one. Then it will be again 89 cents. And this row is the same as before. So actually, this command inserted 2 more rows and changed one existing row. So it changed that row here because it is not up to the end of June 89 cents, but only the end of January. Then it inserts this row and duplicates basically the old row because it will be 89 cents again. And that's the reason why we have 4 rows yet. 4 rows now. And it will be even more complicated. So let's again truncate the table. And let's say we have these 2 rows. And let's say this interval overlaps with the change here. So from February to, let's say, August. Okay, again 4 rows. From January to February, then from February, of course, yeah. Then from February, no, not of course, because this is, yeah, these rows here, there it would be sufficient to have 1 row from February to the beginning of August, but yeah, it is implemented in always the same way. So it is not wrong what we have here, but basically these 2 intervals can be fusion because it's the very same information which was valid from February to the end of June and the month of July. But it's not wrong, and yeah, it is how MariaDB implemented this update for portion of. So this update for portion of is a nice query so that you do not need to care about setting these valid from and valid until manually. You simply say, hey, the price was or will be 50 cents for this time interval. Therefore, we use this update. Here you have the solution. And there's also a delete clause. Do I have a quiz about that? Yes. Delete from products. So let's say we have now these 4 rows here. How many rows do we have now after this delete? We delete the data from the 15th of April to the 20th of April. So there was no price. So the product was sold out. It was not possible to order chocolate bars between the 15th April to the 20th of April. So we have this table, this query. How many rows do we have afterwards? Okay, 10 seconds left. Okay. We have 5 rows now. Okay, now most are correct. Yeah, what do we have? Let's again replay what we did here. I have 2 products. Then there's our update, and we said we wanted to update from the 1st of February to the 1st of March. Then we had this state with the 4 rows, and now I delete the data from the 4th 15 to the 20th of April. Then we have 5 rows. This one was already there. This one was already there. Then this interval, which originally went from March to July, is now only from March to the 15th of April. Then there is our gap. There's nothing from 15th of April to the 20th of April. And this is basically the duplication of the original row. So that here happened the magic in the deletion. So this row here was simply split into 2 rows. So here March to July, but the gap was introduced. Okay, I linked an experiment here where on dbfiddle where MariaDB is used, but we cannot do everything in dbfiddle because when we want to talk later about system version tables, we yeah, the dbfiddle executes everything together, and then we need to try it out. Okay, interesting are application timetables when you have multiple of them and you have foreign key relationships. So let's say we have here our products table, and we have the possibility to subscribe for products. So customer number 1 wants to have a chocolate bar every, what is it, every day or every month or every week. Don't know how often this subscription is. It does not matter. So they have a subscription for the chocolate bar. I want to receive a chocolate bar via post again and again. The subscription was valid from April to October, and in between the price changed. So what we have is now on this subscription table, customer number, product number, valid from, valid until, again a time period. When was the subscription valid? When did he or she quit? And here we have the period as part of the foreign key to the period of the other table. So our term period, which is defined valid from, valid until of the subscriptions, is part of the foreign key referencing the date period, which is the valid from, valid until in the products table. And again, here we have a primary key which is not supported in MariaDB. MariaDB does not support foreign keys, including the time intervals. But this way you can guarantee referral integrity. You know referral foreign key. I'm a professor for databases and I forgot the word. Referential integrity. Referential integrity. So you can guarantee referential integrity now over time intervals. So referential integrity in general means you cannot say that somebody has a subscription for product 17 if in the products table there is no product 17, or customer number 1 can only be written here if there is really a customer with a customer number 1, otherwise you could not insert it here. And for the foreign keys included in the periods included in the foreign keys means you cannot say that somebody had a subscription from 1982 to 1957 because we don't have these intervals here in our products table. So we really must have data that contain these intervals which we use here, so that it is clear that we find prices over the whole period when somebody had a subscription. That's the idea of foreign keys over such application time tables. And when we have foreign keys, we also have the concept of temporal joins. So we now have our predicates that we saw on the other slide, like overlaps, and we use this now in the join predicate. So when you have a subscription and you have products, it's not sufficient anymore to just join on PNR equals PNR, because then you find subscription from 3 years ago with product prices of next week and so on. So you have to match join partners based on the overlappings in the time intervals so that you find really matches here. So customer number 1 has the chocolate bar subscription from April to October, and in between the price changed. So what our temporal join now finds, so first of all, yeah, this product is this product. I omitted the product number column here because of space problems, but this is the product 17, and now they must overlap. So this customer number 1 appears now twice, and with that result we can now compute, for example, total cost of the subscription by calculating the number of days and so on. So I use the customer number from the subscription table and the rest is from the products table. So the valid from is not this valid from here, and the valid until is not the valid until here. I would have to rename those columns if I would need them. So if you want to calculate the total cost of the subscription, you need also s.valid from and s.valid until and so on, and then check what was the price during the subscription. Yeah, and that's a temporal join. Customer number 1 had the subscription during the point where the price was increased. So we see, so the result is again an application managed table, application time table. From January to July, the chocolate bar costed 89 cents and customer number 1 had a subscription within this interval. And when we would have s.valid from and s.valid until in the clause, then we could also see for how long. Yeah, and customer number 2 does not find the join partner with the 89 cents, because customer number 2 started the subscription after the price change, so it does not find this row here as a join partner. And that's a temporal join. We include predicates on the time intervals in the join predicate. Okay, then this was the hardest part, and now back to the example from the beginning. I want to ask a query by traveling back in time. What was the result of this query when I would have asked it some days ago, or some minutes or hours ago? And this is what we call system version tables. The database, and only the database, provides starts and end time for periods. This means you will never have 1895 as a year in the sysstart table. The smallest sysstart value can be, that's the receiver theorem, can be when you activated this feature. So you can not go unlimited in the past, only until where you activated this feature. And you do not have something in the future. So the database tracks your changes. All operations within the transactions should use the same timestamp. That's also specified in the SQL standard. So when you update and delete and insert multiple rows, then you should not have some milliseconds in the generated timestamps. So it is exactly the same timestamp. Which one is not defined in this standard? It should just have the very same timestamps. The SQL standard defines system versions table in the create table command with this with system version. So you have to do 3 things. First of all, add timestamp columns, call them whatever you want. I do not call them valid from and valid until, because that's what I use for application time tables. So I use sysstart and sysend or something like this, because sys is always something where you see, oh, this is something which is not for me, this is managed by the system, but it's just my interpretation. So sysstart and sysend will be generated always as row starts. This is how the SQL standard wants it, that you write it that way. And sysend generated always as row end. So it means when a row is true, when a row is valid. Then you define a period for system time. I think you have to really call it system underscore time. This is not something you can choose. And then the 2 columns here, which are included in the period. And now the most important sentence with system versioning. Without that, it's a normal table with a time period. But here you have now activated system versioning. So each insert, update, and delete will be automatically happening in the table. MariaDB supports shorter syntax, but I don't like that one. You see here, you say create table customers. This is just the form how you define a table, how you learned it some years ago when you learned SQL, and then simply add with system version. This is a simplified syntax which stands for this, but here you don't have an influence how these columns are called, so it's completely hidden, and it's really completely hidden. So you cannot take a look in these columns. They are hidden. These are hidden columns. Here you can see the values. You cannot change the values in that columns, but you see what's happening, and here it's more hidden. So create table customers. Customers already exist, so drop table customers. Then I create the table, and now I insert something, and when you see this insert here, This is normal insert. I don't have to include sysstart and sysend. This is automatically done. And also for the update and delete. Here, this update set email where customer number is 5 is a normal update, and the delete is a normal delete. So I insert something. Bam, there's a customers. So everything looks as always. And as I use the long syntax, the sysstart and sysend columns are shown to me. With this short syntax of MariaDB, these information would be hidden. And then I update something. So peter@example.org is not correct. His email address is peter@example.com. So I take a look again in the table, and as you know it, there is now my change. And when I make a deletion, and you already see this sysstart here is a bit later than the sysstart from before, because this is valid after the update. So 15, 30 and 58 seconds. Now I delete it, and now my customer table is empty. So this is nothing special, but now I have the possibility to query historical data. I can ask an arbitrary query for system_time as of, and now a timestamp. What was it at 13 minutes after 3? Oh, there was no data. And 10 seconds, and 20 seconds, and 30 seconds, and 40 seconds. Aha. Then I can see what was the result of this query, when I would have asked it here. Oh, the email address was peter@example.org. Then I can move a bit in the future. Oh, 59 maybe. Oh yes, now it's peter.example.com. And when I go to 1459, then it's empty. So you can really travel back at each point in time in your table. After executing the 3 queries on this slide, how many rows will select star from customers where customer number 5 return? Do you know that answer? Quick quiz. Very quick quiz. I will give you the solution in 10 seconds. Of course, 0. We deleted everything again. So by default, each query gives us the current state, but we have, with the for system time clause, access to the historical states. So by default, only retrieve the current rows. Empty result because we deleted the customer. Historical queries for system times clause. So I showed you the example for system time as of, and then you specify a timestamp, and then it shows to you what was there at this point in time, the result. And it's also possible to make a time range here for system time from that point in time to that point in time. Then you find a row multiple times. So let's make this here. So what we have here doesn't matter. So then we have multiple times the same row, and we see each change together with a sysstart and sysend. Okay, and now my last slide, just telling you that it's possible to make both at the same time, both application time and system version tables. So you have columns valid from and valid until. The price is 50 cents from the beginning of April to the mid of April. So you track when will the product have which price. And for that table, you also activate system versioning. So with system versioning, and you have sysstart and sysend here to keep updated on updates, deletions, and insertions and so on. And now my favorite query, which does not look complex, but can you explain this query in a text in the chat, please? Don't look in the lecture slides, there is the solution, but what's this query here? Give me, or maybe select price from products. Give me the price of the products for system time as of 1st February for product 17, and then this interval. What does this query mean? And when you understand this temporal tables example, then you understand everything of today. Can you give you some best practices when to use which type of temporal data management? Yeah, you manage different things. So the system versioning tracks when something happened in the database. It's also called transaction time. So you can travel back in the database to give you test. There was an outage on my internet. I hope it's working again. Sorry for that. Nobody is here anymore, but we are almost finished. I give you the solution to the query that I have on the slides, and there was already in the chat a good solution. What should have been the price? Yeah, not between, but on the 15th of February, on the 1st of February, 14 o'clock. So I travel back in time to the 1st of February, and then I ask what should be the price on the 15th of February. What will be the price? Maybe this price prediction is changed again or so, but what I have it here. What was on the February the 1st the planned price that the chocolate bar will have on the February the 15th? So I take a look at the previous state of my application managed application timetable, what the price then would be. Okay, now back to the question from before. I don't know if it was answered before or during or after the internet outage. When should you use application time? When should you use system time tables? System time are normal tables, but you want to travel back and take a look what was the state of the table at this point in time or for this time interval. And the so for example for auditing. And the application time is you want to store changes manually. So store when was the hotel price, how big, and so on. So for things that often change and you want to keep track on the change manually. And with this temporal tables approach, you can combine both. You can combine your understanding when some fact is valid for which time period, application time, and the database system manages the historical states of this table, transaction time or system version table. Okay, a short summary of today. We took a look at the SQL 2011 temporal standards. It introduced time periods. You can define a period, give it a name, and use two timestamp or date columns. Then you have operations on these periods. You can check whether a time period contains a point in time or another period, whether two periods overlap or not. We call it application time period tables when you manually work on these periods, and you can then update something in the past. This is not possible for system version tables. You cannot update the past and you cannot update the future. You update the now. Now again, I'm connected via mobile phone. With system version tables, you cannot change something in the past. You cannot change something in the future. You can only change the current state, and this is tracked. And you cannot delete something in the past. In application time, you can delete something over an arbitrary time interval. We saw foreign key relationships on application time period tables and how to make temporal joins. And now on the system version tables, we took a look at this with system versioning clause that you can use in the create table command to activate system versioning. And when you want to query such a table, by default it shows the current state, but you can access an historical state by using for system time in the from clause. And combining everything is called temporal tables. Okay, I hope the internet connections are okay now, and if not, then sorry for that, and thank you for attending this talk. Goodbye.